domain join. And it works with any method of cloud authentication, whether you're using password hash synchronization or what I'm going to speak about here next, pass-through authentication. It can be rolled out to users in a controlled method by leveraging group policy. And you can register non-Windows 10 devices with Azure Active Directory without the need for any ADFS infrastructure, which is nice. So again, seamless single sign-on. The example that I've got on the screen, you see the user there. Kerberos authentication to on-prem AD, leveraging Azure Active Directory Connect to make sure those identities are synchronized with Azure AD. So when a user signs in from a domain join machine, Azure Active Directory validates that information and then passes that application around to these applications, whether it's a SaaS app, something running in Azure Office 365, all without me having to retype in my password. So password hash sync and seamless single sign-on requires minimal effort. You're only having to set up Azure AD Connect, which you're going to need to do anyway if you want to make sure that your user accounts from on-prem are in the cloud. Your user experience is great because it's seamless single sign-on. It's more secure because it's using seamless single sign-on. We don't have lots of usernames and passwords running around. You can leverage Azure Active Directory multi-factor authentication. Right? Again, this is what we talked about. You don't want to rely on a single thing. Jonathan talked about that in passwordless. You still want to have that second factor of authentication. We talked about that as it relates to the NIST password guidelines, right? We all know passwords are evil from listening to Jonathan earlier. We want to get rid of those passwords. The password policies introduce complexity and not necessarily security, right? So having that second factor of authentication. There's a couple of other things that you get, advanced scenarios you get from this, and I'm going to talk about the leaked credentials report in a minute. We've got leaked credentials. You've got the ability to look at risky sign-ins. I'll talk about that in just a minute. I mentioned smart lockout. I'm going to go deeper into smart lockout, but again, smart lockout being that we know who the good actors are, who are, maybe it's me. I do this all the time. When I'm typing in a password, maybe I flip characters because I'm typing so quickly, and I do it a couple of different times. I don't want to lock out my account for that. Or maybe I'm using an old password. Oh yeah, I reset that password finally after 4 changes. I don't want to lock my account for that. So smart lockout kind of helps in that. No business continuity needed in this situation. Some things to consider: there are delays in replicating the account state. As I mentioned, Azure AD Connect will synchronize identities and password changes when a user is changing their password instantly. But if you're setting it on-prem and moving it to the cloud, there is that 2-minute replication delay that you need to understand. All right. So we started easy, cloud-based authentication. Only the cloud, only leveraging Azure Active Directory, super simple and easy. Then we went to the next piece, which is we're going to use password hash synchronization. That way my usernames and passwords are the same on-prem as they are in the cloud. And we want Azure Active Directory to do the authentication. We're going to go one other step in complexity, and that's with Woodgrove Bank. Woodgrove Bank is a trusted financial institution. They have very strong regulatory compliance requirements in many of their locations. Their CISO has basically stated, hey, look, they've got very stringent policies around data sharing between their internal environment and the cloud. They've got very strict password policies. So bank tellers are restricted to signing onto their systems during specific time frames. Now, this is not a case that we can handle with Azure Active Directory in terms of login. So in this particular case, we need to leverage a different method of authentication. They are planning to move to Office 365, and they are planning to use SaaS-based applications. So these are something that we need to take a look at. We've got a lot of employees present in every region. They've got strong regulatory operations. They do have an on-premises environment that we need to take into consideration, and an on-prem directory. So we're going to go ahead and start looking at the decision tree. So we need Active Directory integration. Do you want cloud authentication with password protection? In this case, no, and they don't have an existing federation provider. And they do also, as I mentioned, their password policy with their login hours is an authentication requirement that's not supported by Azure Active Directory. So in this case, they cannot use password hash sync because of their policies about data sharing. Inside of Azure Active Directory. That logon hours, we currently today, this is where we want to take a look at, okay, in this case, we can't use password hash sync authentication because the login hour requirement still is required to be done on premises through the existing domain controller environment. And we do not even want to consider using something like federation in this case because the additional costs in maintaining those servers and maintaining the ADFS infrastructure. So you've got servers, you're going to have to roll those certificates around, not just the certs from the servers themselves, but the certs from the apps every year. Like that's high support cost. And then if you've got multiple locations like Woodgrove does, you're going to have network equipment like load balancers and so on and so forth. So in this case, we definitely don't want to recommend ADFS if they because they already have ADFS. So we don't want to. Let's see here. Trying to dismiss that piece there. There we go. So we don't want to use ADFS. So Woodgrove Bank may want to look at using a cloud-first approach in this case by still leveraging Azure Active Directory, but using what we call pass-through authentication. All right, pass-through authentication or password-through authentication is an alternative to password hash sync. You get the same benefit of having cloud authentication with organizations, so you can use those cloud-based apps like a Workday, so on and so forth. But you've got on-premises AD password policies that you need to manage. Maybe you've got older existing IT policies that do not enable or allow for synchronization of password hashes, which, by the way, we should go back and reevaluate those with the organizations and talk about it. So what we want to do is we want to pass the authentication request from Azure Active Directory to the on-prem environment, to the on-prem AD environment. So that is known as pass-through authentication. So instead of syncing the password hashes, what we're going to do is deploy 2 or more pass-through authentication agents on-prem. Why 2 or more? Well, because we don't want to have only one and have it go down and not be available. These agents set up persistent connections to Azure Active Directory, and what they basically do is sit there and they wait for password validation requests. So let's walk through this scenario. When a user tries to sign into an application that's secured by Azure Active Directory, let's use something like, I don't know, like let's say Outlook Web App, right? So Outlook Web Access. Here's what happens. The user is going to enter their username and password into their Azure AD sign-in page, right? So I go to outlook.mycompany.com. Sorry, my office mate's starting to scream a little bit here. Working from home is awesome. If the user's not already signed in, the user's redirected to the Azure AD sign-in page, right? So we haven't signed in before. So we're going to enter in our username and password, and we're going to click Next. Then Azure Active Directory, on receiving that request to sign in, places the username and password encrypted by using the public key of the agent. So we have a public private key between the agents and Azure Active Directory. So you see the 2 agents that we're running. You can see that key on my screen here. Keep in mind, one thing that's important to note, the agent doesn't pull for requests, but it receives these requests because these connections between the agent and Azure AD are persistent. So there's no need to pull there. So what we do is we take that encrypted request, the authentication agent retrieves the username and password from the request queue. It decrypts the password by using the private key that we've established. The agent then validates the username and password against on-prem AD by using standard Windows APIs. The reality is, secret here, it's the same kind of thing that what ADFS uses, only it's being run without the massive ADFS infrastructure behind it. So we use the same APIs to what ADFS uses, and then on-premises AD evaluates the request, returns the appropriate response. Yeah, okay, yes, good, success. No, we've got a failure. The password expired. The user's locked out. The agent validates the username and password against on-prem AD of login hours. Then the authentication agent returns the response back to Azure AD. Azure AD will look at the response that it got from the agent and then respond to the user. Now, if the user sign-in is successful, the user can access the application. Now, in this case, in this situation, we gain access to the same type of seamless single sign-on abilities or capabilities that we have. But what we will lose is access to We support Smart Lockout, but we don't support the leak credentials report. Now I want to talk about the leak credentials report. Azure Active Directory, and one of the huge benefits of Azure Active Directory is that it's part of a series of services that share security information that's gleaned from the millions and millions of authentications that we get every single day. Security information that we get from our cybersecurity group here at Microsoft, from partnerships with law enforcement agencies, and from the work that we're doing in terms of trolling the internet, looking through, trying to find credentials that have been leaked through various breaches. I think the Target breach or some of these retail breaches that are out there, passwords that are out there on the dark web, usernames and passwords, and what we do is we take those usernames and passwords and we hash them using similar algorithm, similar algorithm to how we do the password hash synchronization, and we compare the hash that we got out of that service. So maybe there's your leaked credentials came up because my username and password was part of a breach. It's out on the dark web. Gotten a hold of it, we've hashed it using the same algorithm, and we compare that to what exists in the same service. And when we find a match between those hashes, again, we don't have access to the passwords. We have access to the hashes, right? That's what we were talking about before with password hash synchronization. When we compare those two things and there's a match, we alert the administrator. And we alert the administrator through something that's known as the leak credentials report, which is a report that you can pull up and it shows any users in an environment that have a leak credential. Or if you have P2, so Azure Active Directory P2 M365 E5, you can actually take this process and automate it by leveraging the user risk and conditional access. And what it will notify is like, hey, this is a risky authentication because it's the same username and password that's been logged in a breach. So instead of just locking the user out and saying, no, you can't log in and talk to your administrator, you can actually, if you have self-service password reset already enabled in an environment, have that request denied to log in, please reset your password. And then through the password reset process, I certainly hope you've got multi-factor authentication enabled there as well, which makes sure that it's a good actor that's doing the password reset. And then once the user resets their password, the risk of that user session, of that authentication, goes down and they can continue to move on. And it's all automated. If you're just using the P1 functionality, you do have the access to this leak credentials report. Now, it's important to note that using password hash sync, we do get access to this leak credentials report because we're doing the synchronization of the hashes. Using pass-through authentication, you do not have access to that unless you do password hash synchronization alongside a pass-through authentication. And let's talk about a scenario. Why would I want to use that? I mean, instead of just using password hash sync, let's go back to the logon hours scenario, which we currently don't support inside of Azure AD. In that particular case, we need our on-prem infrastructure to do the validation or do the authentication. Maybe there's a policy that states you can't use a cloud-based IDP for some reason. Let's go reevaluate that later. But for now, we can't use it just to solely do the authentication. It has to be done on-prem. Well, in this scenario, you still need pass-through authentication to do that authentication. But we want to have the hashes synchronized so that we can get access to this link credential report. So when you have both enabled, pass-through authentication is the method of authentication, but you still gain the benefits of the link credentials report. Make sense? Now, all of this is documented. We have a how-to of terms of how it works, of how pass-through authentication works in our docs page. But in addition to that, there's some guidance that I want to give you in terms of deployment of multiple pass-through authentication connectors. And again, this is wizard-based deployment. These connectors are so simple to set up. So install multiple pass-through authentication agents so that you have high availability. It's important to note that this is for HA only. It does not provide deterministic load balancing. In other words, I can't go in and say, oh, well, if I'm located in this site, I use this agent. So when you're starting to measure things, a single authentication agent, think 4-core CPU with 16 gig of RAM, can handle between 300 and 400 authentications per second. Because of this, most scenarios, you're pretty good with just having 3 authentication agents for high availability, right, and capacity. And you want to install these agents close to your domain controllers in terms of network closeness to improve sign-on latency. So to estimate your network traffic, you kind of take the payload size with the number of agents, and there's a mathematical formula that's in our documentation, and you can actually use that. I just say 2, at least 2, minimum of 2 to 3 agents is necessary for most environments. So let's take a look at this in terms of pass-through authentication. Why did we decide this? Well, obviously, as we mentioned before, pass-through authentication was needed because of the data sharing requirements and then the hours that we had here. So agent deployment effort. So we have to deploy the agents. We have to update those agents, but there's no extra networking in terms of effort. The user experience is still pretty consistent. You get seamless single sign-on. You can still leverage Azure AD MFA. You do get smart lockout. You do get to control account states in terms of maybe I want to use an alternate ID, maybe I want to use logon hours, some of those things. You only get the ability to use the leak credentials report when you enable pass-through authentication in conjunction with password hash sync. But listen, you've got to have multiple agents to ensure business continuity. Still, again, consider password hash sync if possible, if you can do that. And then, of course, as always, only the applications that are using modern authentication can do the seamless single sign-on in this case. And I've talked about seamless single sign-on here. I wanted to bring a diagram in that we have here in terms of the flow. This diagram on this slide is the sign-in flow of how seamless single sign-on works. And I want to be cautious of timing here. Basically, what happens, the user tries to access an application. If they're not signed in, we go and look at what is the username and password that's in the existing Windows session. We pass that along to Azure Active Directory. Then we query a couple of endpoints. If it succeeds, we retrieve a Kerberos ticket. We forward it to Azure Active Directory. Azure Active Directory is going to decrypt that Kerberos ticket, validate it, issue a SAML token to the application, then the app submits the SAML token to Azure AD's endpoint to validate that token and give the app an access token and a refresh token for that particular resource so that the user can gain access to the application. Again, fully documented this entire flow. Everything else is in our docs page. It's linked from that doc that I initially showed you an example of how password hash sync works. It's the next document down from that. I want to note a couple of things. Seamless single sign-on creates a computer account that's named Azure AD SSO ACC in your on-prem AD in each forest. That computer account needs to be strongly protected for security reasons. Only domain admins should be able to manage that security account, and you need to make sure that Kerberos delegation on that account is disabled and that no other account in AD has delegation permissions to that computer object. You'll want to also store that computer account in an OU where they're safe from accidental deletions. You don't want these being deleted. And make sure that, again, only domain admins have access. So this is one of those service accounts that we want to go ahead and protect. All of this information is also fully documented in our documentation around pass-through authentication. So one last bit on Smart Lockout. As I mentioned, it assists in locking out bad actors who are trying to guess your users' passwords or they're trying to use brute force methods to get in. Can recognize sign-ins coming from valid users and treat them differently from one of attackers and other unknown sources. So it basically locks out the attackers while letting your users continue to access their accounts and be productive. So by default, Smart Lockout locks out the account from sign-in attempts for 1 minute after 10 failed-in attempts. That's the default, right? The account locks again after each subsequent failed sign-in attempt for 1 minute at first, and then longer durations throughout it. Smart Lockout is always on for all Azure Active Directory customers with default settings, just so that you're aware. And it uses familiar location versus unfamiliar location. That's really how we differentiate between a bad actor and the genuine user, right? We understand what users' behavior is and what familiar locations are to those users. And we can understand, because we understand that, we can make a determination of which one is a good user versus a bad user. One important note, an administrator cannot unlock the user's cloud accounts if they've been locked out by smart lockout capability. You must wait for that lockout duration to expire. So please be aware of that. So let's take a look at our Azure Active Directory authentication tree. In this case, where we use pass-through authentication, right? The decision-making that we had through the auth tree. And you see that because we had an authentication requirement that was not natively supported by Azure AD for Woodgrove, basically, maybe we're using an on-prem MFA server, maybe we've got policies, maybe we have to use smart cards or certificate-based authentication. That's where we have to use pass-through authentication and federation. Quick note on federated authentication. So again, we talked about the reasons why we wouldn't use federated authentication. Federated authentication is usually only required when customers have a hard requirement that does not support, that Azure Active Directory does not support natively. We have gotten so much better. I'm going to talk a little bit more about federation in my next session, so I'm not going to go too deep into it here. We've gotten so much better in terms of the scenarios and the apps that we support natively through Azure Active Directory that federated systems typically are not needed because of their because it requires a more significant investment in on-prem infrastructure. Most organizations only choose federation if they already have it. And if it's a strong business requirement to use that single identity provider, where you can't just go, hey, look, we want to use Azure AD as that single provider. It's more complex to operate. It's more expensive, right? Some scenarios that we have, smart card authentication, certificate authentication. If you're using third-party authentication providers and it's not Azure AD or on-prem AD, so it's super complex, requires a farm, proxies, DMZs, certificate rollovers. You do get seamless single sign-on, and you can leverage Azure AD MFA. You also can support more advanced scenarios here, though we are getting better at these in terms of being able to support some of these things. Obviously with passwordless and FIDO, some of these other things. Remember, requires load balancers. Consider using password hash sync when you're using this, but also you've got an on-prem footprint. So at the end of all this, turn on password hash sync, for whatever authentication method you choose, right? Turn it on. We need to have, you want to have that report, right? High availability and disaster recovery have to come into play here when you're using anything on premises, whether that's pass-through authentication or ADFS or federation. Always recommend using cloud authentication wherever possible. When you migrate to cloud authentication, we have deployment guides out there that help through that one-time deployment and synchronization. We also have a new feature, which is called staged authentication, which allows us to do gradual rollout of changing your authentication methods from on-premises to the cloud. Some resources that are available, take a look at aka.ms/auth-options. That is basically this presentation, a very shortened video and access to all the documentation that I referenced. We have our migration guides at aka.ms/aad-auth-migrate and our deployment plans, which help you walk through a deployment with detailed planning guidance and stakeholders and everything else that we need. And then for security considerations regarding passwords and accounts, I always have people take a look at our AAD data white paper, which kind of talks about why we should use particular authentication methods. And with that, that's this section done, and I'll open up to a few questions. I'm on deck again, and I can tell you that my next session doesn't go near as long as this session, so we can do some Q&A and I'll still end on time. So I know, Ty, you've got the magic slides, right? With some of the questions that we can vote up, and we'll take a couple of these questions before I move on to the next session.
Yes, thank you, Joey, for all of the questions. Also, kudos to the team in the background that have been answering many of your questions already, but I know we're running short of answering all of them. And so if you can just do the same thing here again, go to the browser that you see on top, go to the link, the URL on top of there, and start voting on the questions. The questions that weren't answered in the chat are already shown here. So this is your chance to ask additional questions or vote on those that are also a question that you have.
Give you a minute to vote up some of these questions. Okay. I'm going to answer one of the questions. It's not the top one, but it's something that I've seen pop up quite regularly, which has to do with how does this work when we use a third-party IDP like an Okta? So again, in this case, what functionality is available is dependent upon your IDP. So if you're using Okta to do authentication and you're not using Azure Active Directory, most of what I talked about doesn't come into play. I encourage you to take a look at what Okta supports if that's the way you're going to continue to run, though I would prefer that you use Azure Active Directory, obviously, since I'm on that engineering team. But a lot of this kind of falls by the wayside because that becomes your IDP, so you fall under the rules of that IDP. And that's Okta and some of these others, CA, some of the others that we have out there. So how does let's take a look at Azure. I see a bunch of questions on the same line in terms of monitoring Azure AD Connect, making sure that it's successful and it can alert. Yep, so that's absolutely something that you can do, and you can actually take the logging and the information and move that into your SIEM tools. We do recommend that you have multiple Azure AD Connect servers. Now, this currently today, our Azure AD Connect servers, it's kind of like there's one that's functioning and that's actually doing the synchronization, and then you would have a secondary one that's offline that is doing the synchronization, but it's not the primary agent, and that's in case of failover. So in that case, you do need to take a look and take a look at the logging, make sure you're monitoring that logging within your systems to know when if one is not synchronizing. Azure Active Directory has an agent that's called Azure Active Directory Connect Health. And this agent is what kind of tells the service as to whether or not things are running or you're having synchronization errors. So you're going to want to make sure that you're monitoring that Connect Health. It's in the dashboard. I'm going to show an example of it in my next session. But you're going to want to make sure that you're monitoring that to make sure that your synchronization is functioning. Let's see. Do we need premium subscription of Azure AD for passwordless authentication? Yes, absolutely. Passwordless authentication is part of Azure Active Directory Premium. How does Azure AD SSO work with applications that run on Linux or Unix platforms? This is a great question. It has absolutely nothing to do with the platform and how it runs, of what the platform it's running on. It's does the application support the use of modern authentication protocols such as SAML and OpenID Connect? So it doesn't matter the platform that it's running on because we talk open standards. I'm going to cover that more in the next session. Same with single sign-on with SAML 2 applications. Again, it's just SAML. So what we're doing is we're passing that request in. If you take a look at the documentation that talks about SSO and that whole workflow process, you can actually go in and see, and I talked about it at the end of my session, where we go to Azure Active Directory, and what we do is we get the tokens that are necessary. We get the refresh token and the access token, and we pass that through. That's how it works there. So it's all standards based. So however SAML works and that application works is how our service works with that. Let's see. Does the UPN of a user have to match with the cloud AD account for SSO to work? Example, local AD UPN is contoso.local and the cloud UPN is contoso.com. You can configure it to work with the alternate ID, the alt ID, and that's fully supported and we've got it documented. But there's one caveat to using alt ID. And this may or may not be a game changer for you, but most new features that we add and we configure once we enable new functionality inside of our service are designed to use the main factor or synchronization ID, which is generally the UPN. When you use an alternate ID in this case, a lot of times there's a big lag time between the feature and function becoming available by using the alt ID. So that's one of those things that you want to take into account. If you can match it, great. If not, there's other ways that you can do that synchronization to run. Where's the link credentials report? So the link credentials report is in. I'm going to take a look here. I'm going to just take, if you can give me just 30 seconds here of me just being a little quiet. Let me see if I have that. I want to make sure I have something in it before I show you inside of my demo environment that I'm going to use in my next thing. But it's available through the portal. I mean, short answer.
Joey, I'll paste the link on the chat.
Ah, perfect. Thank you. Thanks, Litis. Yeah, versus me trying to do it on the fly here. Can you use the popular pass to hash in Azure Active Directory? No. Just the way that it works. We're using different. You're changing from hashes to tokens in this particular scenario, but we've actually documented some of those things. Let's see. We addressed the Okta issue. Can we monitor Azure AD Connect? Yes, as I've mentioned. Azure AD Connect Health is the agent that you want to use. You want to set up alerting based on what you get out of Azure Connect Health. This is an interesting question. I want to go ahead and address this. When can we abandon on-prem AD and go cloud only? So the answer to that is if all of your applications support modern authentication, SAML, OIDC, and all of your users are all inside of Azure Active Directory, and you no longer need on-prem AD to do anything. There's no policies, there's no corporate security policies or anything that mandate that you're on-prem. So if the functionality inside of for cloud-based authentication works for every one of your users and all the devices that you have to manage and deal with, then you can make that decision. So there is no straight answer in terms of when. That depends on each organization and whether or not the capabilities exist there. All right, so I appreciate all of the questions that we have here. I do want to be conscious of time because I do want to get into this next topic where we start talking about applications. So let me go ahead and thank you, Ty, for collecting all the questions and the rest of my team that are answering some of them.
You're welcome. Take the screen back whenever you're ready.
Yeah, just.
So now we'll move into the next session. It'll be the same speaker, so Joey will have two presentations. We talked about the different authentication options before, and now as next one, and that is the last session for today, Joey will be talking about SaaS applications with Azure Active Directory. He'll start sharing his screen in a minute, and so I give him 30 seconds break of talking.
Quick change.
Into the next session. Thank you, Joey.
Yeah, thanks, Katya. Had to quickly open up another slide deck and take a drink of water too.
And please keep your questions coming. Again, we will continue to answer your questions in the chat window, but we're trying to do a similar exercise again after this session here with the polling. Keep them coming. We'll try to address them as many as we can.
Perfect. Thanks, Katya. And also, as I mentioned before, the definitive source for all things related to Azure Active Directory is our docs site. And I know I keep saying, go to the docs, go to the docs, go to the docs. But our team is fantastic at maintaining and updating our documentation. I know it didn't always used to be that way back a few years ago, but we've made significant strides. And a couple of my colleagues that work over in the docs team, I'm always hounding them and pestering them to make sure that it's up to date. And then also, if there's something that's missing in our documentation, there's a little comment box at the bottom. You can put it in there. Or even better, if you're smart at GitHub stuff, you can actually suggest a change yourself. It goes right to the PMs, and that's a whole other story. But I just encourage you to use docs. All right. So I'm going to transition now. We're not going to talk about how which authentication method we're choosing. We want to talk about app integration with Azure Active Directory. So just as a reminder, my name's Joey Snow. I'm a program manager in the identity engineering team. I work on partner strategy, so I work with partners like you who are all attending this call to help in terms of readiness and strategy around Azure Active Directory, and in particular, making sure that we get the feedback from you to make our product better. All right, so in this session, let's talk about why do you care? Why do I care about application integration with Azure Active Directory? What does it really mean to modernize your application? How should you build your migration strategy in your customers? And then I'm actually going to finish off with some go-dos that you can do for Monday morning, next Monday morning. So it's important to note, what I want to do is, I want to set this up a little bit differently. This is not a conversation where I'm going to be going into every single application and showing you how you actually change the authentication methods. This is talking about why you need to make these decisions to move to a more modern authentication platform. There's significant business possibility for you as partners in terms of application modernization and in ensuring security for users, ensuring more modern authentication and the reasons for doing it, particularly when we start looking at how things are being affected in today's world of COVID and post-COVID. Working from home has really highlighted application integration. A lot of customers have immediately jumped to VPN solutions. And it's amazing what happens when a VPN that's used to support maybe 20% of the entire workforce moves from 20% to 90% or 100%. And what happens when you're reliant upon a VPN infrastructure to do all of your application access and the stresses that that can cause on that infrastructure. When sometimes things like authentication can actually be moved outside of that, you can start to leverage things like third-party SaaS-based applications and let all the authentication and access be handled through something like Azure Active Directory. So this is, you know, a lot different. When I originally built this conversation, we talked about the story and we talked about the why and why we move. It's actually been even more highlighted in today's work from home infrastructure and story, and it's something that's important, which is why I kind of get on my soapbox here when I start talking about applications and when I start talking about making sure that we've got secure access for our users and that we can provide the best experience possible for our users. So what I'm going to talk about is I'm going to kind of show a couple of examples of things that I've seen today in environments. Please note this is a caveat of that app story was pre-COVID. So a lot has changed in the last few weeks. But we're going to talk about how we look at applications inside of Microsoft. We'll talk about Active Directory, Azure Active Directory integration of applications. We'll talk a little bit about why modern authentication. So let's look at applications today. One of the key things, and I just talked about this related to COVID and the VPN solution, is that not every single application actually requires to traverse the on-premises network. And it's important to note, we're breaking the four walls. And particularly in this post-COVID space or in this COVID-19 space where work from home, your security factor is now no longer the four walls that you have inside of your environment in that and those, you know, VPN devices. You really need to start thinking about, I've got applications that have data on them that are running outside of my four walls and outside of my premise. So what is it that I use to control access to these applications and the data that sits inside of those applications? I mentioned it in my previous session, but it really is identity. So identity really becomes that control plane, right? It becomes that central piece. It's the guardian of the front door that makes sure that my authentication, that identity that I'm using, is a known identity. I know who it is. It's protected, right? It's protected against being leaked. And we have other methods of authentication. So when you look at applications where network traffic, it might be something that's running on-prem, but maybe it has to reach out and connect to a cloud service or another service running maybe in Azure. Maybe the data resides off-prem. Think about a scenario where maybe all of my user data is no longer stored on a file server located on premises. Maybe we've had to, because of work from home scenarios, light up something like Dropbox or OneDrive for users to store their data, because you don't want to be sending these big documents over the VPN connection. You may have legacy identity stores. You may have that application that's sitting on some server somewhere. That's it, you know, running on an old platform, that Windows NT device or that Windows 2000 server. Believe me, there's still some out there. We don't like to talk about those. Some legacy database of usernames and passwords that's not protected, right? I've dealt with a customer that has, actually, it's a database that's sitting inside of Access, the database, Access database. It's an application that runs a considerable part of their business. It's running on this old outdated infrastructure. So multiple identities are needed. Maybe they're using network protocols and network traffic that's being transported that is not secure. That wasn't a problem when everything was on-prem, right? You could protect it because nobody was accessing anything remotely. That's different in today's world. And then, that outdated infrastructure, that stuff that's been sitting around for a long time and it isn't using modern protocols, it's a security risk. It's something that we have to address. So when you break down these types of pieces, how we see applications is we see them as SaaS applications, or we look at them as LOB or line of business applications. So SaaS applications can be server-hosted applications that are applications that your environment is built that's hosted inside of something like Azure, Amazon, or cloud-hosted SaaS-based applications, something like an Office 365, a Box, Dropbox, Concur, so on and so forth. Those typically use more modern authentication protocols like SAML and OIDC, OpenID Connect. Internal line of business applications that are using things like Windows Integrated Auth or LDAP or header-based authentication. Oh, goodness gracious, basic forms-based auth. Boy, I shudder at that, and I'm sure the security people just do the same thing, right? Previous versions of SAML, WSFed, also OIDC and OAuth modern authentication can also exist inside of those LOB internal applications. But we need to be able to support and integrate this application, integrate applications to Azure Active Directory, which is the preferred identity provider moving forward, so that we can get seamless single sign-on and ensure that the credentials, the identities that are being used to access these applications are protected. So particularly third-party SaaS-based applications, which Office 365 is not a third party, it's a first party because we own it, but think of something like a Box, Concur, some of these others. Those are applications that we have listed in our Azure Active Directory app gallery. There's over 3,500 today, and it's growing every single day, about how to ensure that we are informed of those so that we can actually get them added to the app gallery. The benefit of them being inside of the Azure AD App Gallery is that we have a fully documented process of how you configure authentication to work with Azure Active Directory. So it's a step-by-step document. Server-hosted apps like SharePoint, Taleo, about our legacy applications or those on-prem-based applications. When you look at something like Integrated Auth or LDAP, header-based auth to a certain piece, or goodness, that forms-based auth, these are all things that you need to look at modernizing the methodologies, but these are things that you really want to look at moving, or as I show here on my slide, using something like an application delivery controller, network delivery controller, the F5s of the world, Zscaler, Akamai, Citrix's NetScaler works here as well, where you're publishing those applications behind those devices. All right, so those are potential solutions to deal with. You can use Azure Active Directory domain services to move your LDAP-based apps from on-prem into the cloud, but it still doesn't replace getting or refactoring the authentication method to a more modern authentication protocol. And these are key. The reason why you want to use the more modern authentication protocol for a user session into, say, the Windows device. But you also want to be able to control multi-factor authentication in a multitude of scenarios. And I'm going to talk about conditional access, but the example that I'm going to use to kind of help you understand what I'm talking about is, let's say, for instance, that I'm traveling and I go to that amazing malware-infested machine that's sitting in the hotel lobby, and I need to get a piece of information from a document or make a change to a document. I can actually, through conditional access, that application, as long as it supports modern authentication, I can do an MFA challenge to make sure that I have access to that information. But more importantly, I can also leverage some of the other tools in our security products at Microsoft to actually make sure that I can't save when the scenario is necessary. Is why you want to start modernizing your application's authentication protocols. I think most of us today can understand that, because we're now starting to access things remotely. Users may not even be using a corporate-owned device to access data and applications in today's COVID world. They may be using their home PC, and we need to be able to do that authentication challenges when necessary. If I'm just using a normal application, I'm just using the Salesforce app to enter in information, that's great. But what if I start going in and looking at different customers' information? What if I start going in and looking at, maybe it's an internal HR system. What are the salaries of the CEOs? Maybe I want to be able to protect that data and require an MFA challenge for that. This is exactly why we want to use modern authentication. Modern authentication also allows the ability to include additional information about the device. We call this hybrid domain join. As I mentioned, you can use MAM policies for mobile devices. The device information, go back to the scenario I talked about with that malware-infected device in the lobby of the hotel, right? I know that that's not a managed device, so I'm not going to allow us to store any information on that. So in this case, it's really important. Modern authentication really gives us more information, more tools to protect, and it's also more information that an attacker has to guess or correctly spoof, which is good news for those of us who are protecting these applications, right? So it's not just a username and a password that I have to have anymore. I have to have the multi-factor, right? Oh, I have to access this thing from a device that's located on a particular network segment, or maybe this device has to be managed. So we really start looking at this from two perspectives. It's all about increasing the security of the application and the data that sits behind it, and maximizing productivity for your users. And then once you get those two pieces covered, you really start to enable better collaboration, because you're able to use, again, that same single identity to do things. You're able to share that identity because it's a modern identity platform with other organizations that are leveraging the same thing in terms of B2B scenarios, business to business or B2C. Increased signals intelligence, just the sheer data of information that we get. I'll go back and talk, reference the piece that I talked about in terms of risky sign-ins, just as an example of the amount of signals intelligence that we get. And then really, once you get to a unified strategy where this is our identity authentication strategy for all applications, and you can get that agreed to across the board, a lot of the infrastructure complexity or the application complexity inside of an environment can be significantly reduced. So I want to focus on these two key pieces: increasing your security and maximizing the productivity of your users. So in terms of increasing security, one of the key things, once you modernize and you start leveraging a single IDP or identity provider like Azure Active Directory, you can gain a single view of all of the applications, whether they're on-prem, whether they're a third-party SaaS-based application, whether they're a cloud-hosted application running in AWS, Google, another scenario, or they're an on-prem application, like a web application, or maybe an internal LOB application. So in this scenario, taking a look at this diagram, you see that we've got a bunch of things that are kind of feeding and connecting with Azure Active Directory. One of the key pieces in securing your identity infrastructure is by having a known single source of truth for the identities that are created and managed. And that's part of the governance scenarios that were talked about earlier today. So when you look at this, one of the key pieces to having that single source of truth is really making it simple. Today, identities are provisioned in a number of different ways, and they can range from basically doing CSV imports of text files to having PowerShell processes kicked off that go and grab a text file or another file from another HR system, to even having the junior administrator, whoever that person may be, get a list of users and have to create the usernames and passwords. And that's all fine and good for creating them. What happens when they leave the company? What is that process there? How do you ensure that the access has then been removed? Particularly when you look at the fact that they may have access to third-party systems that are located in the cloud, right? Like a Salesforce or a Workday, Concur. So in this scenario, Azure Active Directory actually has the capability to do provisioning. Provisioning is done in a couple of different ways. We have inbound provisioning, which is, in this example, you see Workday, you see SuccessFactors, and then Oracle, which we have in preview as well, where our HR applications can actually provision the Azure Active Directory account. And then you have outbound provisioning, which is where Azure Active Directory can provision the user accounts in other applications, like a Salesforce or Concur, Box, et cetera, et cetera. So think about this. I joined the company. In this case, we use Workday, an HR system that's a third-party cloud-based application. When I join the company, and if I'm going to join the sales team, my identity is created from Workday directly into Azure Active Directory, and then it can be synced to the on-premises AD that we see here through the Azure AD Connect process, which I talked about in the previous session. And because I'm doing password write-back, I can sync these identities. So I can have this single source of truth, this Workday piece. And then because I'm in the sales organization, I travel a lot. And because I travel a lot, I need to use Concur, the Concur system, which I talked about, which is how I book all of my flights. I want to make sure that my user ID and password is the same in the Concur system as it is that I log into everything else. So Azure Active Directory can do an outbound provision to create that identity located in that third-party SaaS application. And then let's say, for instance, I move from the sales organization to the support organization. Well, the support organization no longer travels, right? So I need to be able to deprovision that account from Concur when that process happens. Or maybe when I'm terminated, also deprovision that account from all the places that it was provisioned, which is where, again, managing all of your apps from one central location, Azure Active Directory has the capability to do this. Well, how is provisioning done? Well, it's done through using open standards, the same standards that our SaaS-based applications use. So we can actually extend that provisioning to our on-premises and our applications as well, so long as they support the more modern protocols. Which is, again, why do we want to get modern? You want to get modern to better secure, and provide a better user experience. So connect your workforce to any application by centralizing that management from the cloud. Ensure that they've got streamlined access with single sign-on. And then we can improve app discovery for your users because we've done a bunch of work and enhancements in the My Apps portal, which shows users, it shows them all of the applications that they potentially have access to. So with centralized management, we increase that security and we give a better user experience through that app discovery and through single sign-on. How do we better protect and govern access to applications? It comes through enabling strong authentication. If you're implementing and you're turning on multi-factor authentication for everything, for every time they request something, the user's experience is just going to be horrible. They're going to get those messages in their authenticator application constantly and having to click them. What happens when your users are just clicking everything? They don't think twice when they get an MFA prompt. They don't think, did I really try to access something? Should I really approve this? So you need to use intelligent access policies, and I'm going to talk about that through conditional access. I'm going to talk about that in the next slide. You need to secure your access to the apps with automatic provisioning and deprovisioning, which I mentioned just previously. And then most importantly, you want to monitor and audit the access. And you don't only want to audit who accessed something. A lot of businesses require you to know who has the potential for accessing something. And this is why moving to a more modern identity provider, where that has these governance capabilities built in, are going to help protect access to those applications. So while your network walls have come down, and they probably have today, and your customers are dealing with this today, your security does not have to be impacted because of this. So how we primarily deal with security and protecting these identities and protecting the applications inside of Azure Active Directory is conditional access. So we also have this other piece, which is identity protection, which is a P2 or an E5 feature. I'll get into that in just a second, but I want to very, very quickly just talk about conditional access. I don't want this slide to be intimidating to anybody. It's very, very simple. You have a set of conditions, and based on those conditions, you have a set of controls, and those set of controls can be applied to a number of different applications, whether they're third-party cloud, Microsoft Cloud, or on-prem LOB apps. So in this case, your conditions could be where the user is coming from. And by the way, we support conditional access on identities coming from other identity providers. You can deal with devices. Are they trusted devices, compliant devices, managed devices? What are they? Where are they coming from? The physical and virtual location, are they coming from the corporate network? Are they coming from a geolocation? Maybe I'm running a business here in the United States, and I am never, I'm never going to see authentications coming in from a third party, a third region. And I want to just protect everything. All the stuff I ever do is only going to come from the US. That's geolocation decision that you can make. And then what are the applications in the authentication method that I use? I want to ensure that all my users are authenticating using modern authentication versus legacy. And I want to make sure that if they're using a browser, they're not using a Tor browser or an anonymizer, right? These are all things that can be conditions that we use. And then once we take these conditions, we have controls that we can apply to those conditions and to that access request. You can allow access, you can block access, you can limit access. Let's use the example that I gave earlier of that malware-infested machine in the hotel. We limited the access, right? We said you can access the data, but you can't save it to that device itself. You can only save it to a known trusted location. In this case, it was OneDrive. Require multi-factor authentication. So this is what's interesting. Multi-factor authentication, when you do it in a conditional access based, I don't get prompted all of the time. I get prompted when something changes, or I get prompted to access a piece of information or an application that is what we decide is higher level security, right? So I can access Word and Excel and PowerPoint all day long, but the minute I go into Salesforce and I access customer data, I want to be prompted. But I only want to be prompted if I'm coming in, maybe I trust if you're on my corporate network, I'm within the four walls and I'm on a managed device, even though I'm on the same PC using the same identity and I'm accessing it from home, maybe I do want to do a multi-factor challenge. You can also block legacy authentication and force password reset, assuming you have self-service password reset. I don't suggest in this case if you don't have SSPR, because you're just going to generate a bunch of help desks. 170 terabytes. This number has grown, by the way. This slide was only built 2 months ago, and that 171 is significantly higher now. And we apply machine learning algorithms to understand what the risk of the user account is and the user sign-in, as well as the session risk. So let's use an example here. My user sign-in risk would be low because I did a multi-factor authentication. And my user account has not been affected by some breach of a system, right? It's not an elite credentials report anyway. My session risk could be very high because maybe I'm trying to access something through an anonymizer or a Tor browser, or maybe I'm accessing it from a geolocation that's not allowed within the company. So our evaluation engine, instead of having to look at it, we assign a score based on the behavior. So a great example of this is when I travel. I do a ton of travel in my business where I work with partners and customers and I get a chance to speak with them. At least I did before COVID. A lot of times when I would come home, I wouldn't be multi-factor challenged for things if I was accessing, you know, some of the standard stuff that I already previously accessed, because over time, our services have noticed that about an hour after he leaves the Redmond office, he's logging in from a Comcast location in Redmond, Washington as well. And this IP address happens to be the same all the time. That looks like it's his home. So maybe in this case, unless I'm accessing something that does require that additional challenge, maybe I don't prompt him for MFA again. And so that session is secure. But maybe next time I put my machine to sleep and I fly to London, and I'm logging in from a hotel in London that it's never seen me before. Maybe we want to apply some additional challenges there because my session risk has increased, right? That's not to say that it is, you know, red alert, block everything. Maybe I just want that extra protection of doing the multi-factor authentication. This can all be handled through conditional access. So the way that I look at it is that you've got standard conditional access, which is administrator defined. And then you've got the risk-based conditional access, which requires a P2 license. That's when you're using all of our algorithms and our machine learning to understand user risk and session risk. And then when we identify these risks and these risk events, you as an administrator can actually go in, if we've identified something that looks risky to us, but that's normal behavior for you, you can actually go in as an administrator and you can go in and say, no, this is not a risky thing. This was not a risky sign-in. And we'll actually learn from that, and we'll continue to process to each session. And it's not just a one-time thing. My user risk and my session risk are always evaluated. They're being continually evaluated through my session when I'm accessing apps. Okay, so let's talk about delivering that consistent single sign-on method to legacy applications. It's great if it's a modern-based authentication and a modern app, and I can use that and I can connect it through Azure Active Directory. Third-party SaaS app, it's an Azure Active Directory app gallery app. Maybe it's an internal LOB app, it talks SAML, so I can connect it to Azure Active Directory. What if I want to use something like MFA or being able to use conditional access to allow applications on apps that are a little outdated? Well, if you can put those applications behind those networking and delivery controllers like an Akamai and F5 device, this is actually possible to do today through the partnerships that we have through F5, Citrix, Zscaler. And we have the documented process and deployment guides out on using what we call secure hybrid access. That's one way to do to allow access to these pieces. The other thing, we have this feature. It's an Azure Active Directory Premium 1 feature, so P1 or E3, which is known as Azure AD App Proxy. And what Azure AD App Proxy allows us to do is it allows us to access on-premises applications without using a VPN. And so what it is, it's an agent that you install on-prem. And when a user is trying to access an application on-prem, it contacts Azure Active Directory and you can actually proxy through to that application. Now, App Proxy does not change the, App Proxy isn't enabling these other applications that might be using, say, like LDAP or I shouldn't say certificate-based auth because that's coming, but we've talked about that. But other not legacy authentication protocols. That's what the networking and delivery controllers do. Azure AD App Proxy allows applications that are located on-prem that use more modern-based authentications to be able to access those apps without using VPN solutions. All right, so I spend the majority of my time talking about why. And it's important to understand the whys behind it and why this is important to start talking to your customers about getting modern. The examples that we're dealing with in today's world, the post-COVID world, shows that the four walls no longer matter. And you really have to be able to have these controls on a per app basis. And these apps need to be able to support those controls, and that the identities that are being used to access those applications are secured and protected. And that your users have the best experience possible so that they're not going around you and they're not creating multiple usernames and passwords. So how do you start in terms of migration? So we'll talk a little bit about collecting your facts and app categorization and prioritization and tools that we have, and then we'll get to that Monday, what you can do on Monday slide. The first thing that I suggest, amongst anything else, is when you work with your customers, when you go in, you need to immediately work with the business groups and with the IT organization and the company as a whole to establish a new application policy that states, from this point on, new applications must support modern authentication and are using Azure Active Directory for authentication. You can do this in an environment that has hundreds and hundreds and hundreds of applications. You can do this in an environment that is already more modern, and they're already using SaaS-based applications to access things. Establishing that line in the sand ensures that everything is going to use Azure AD from now on. Even if you've got ADFS on-prem today, you're not going to add additional SaaS applications to Azure AD. You want to, additional SaaS applications to ADFS. You want to use Azure AD, not ADFS. So establish that policy, first and foremost. Then the next thing that you want to do is do a discovery of the applications that are out there. There are a number of different ways to do this. You can use the app, you can do app inventory, you can use a CAS-B solution. In our case, it's MCAS, and we'll talk more about that tomorrow. To do discovery of applications. You can, one of the most effective ways is actually interviews with the stakeholders, find out what applications they're using and that they need access to. You can start sniffing traffic on the network. You can do log analysis. And if they're using Federation, we actually have a tool that enables you to discover the applications that are on ADFS and